In this lesson, we'll look at mean of grouped data. The arithmetic mean can also be prepared for grouped data. In such a situation, the class mark or midpoint of the individual class interval is used for the S column. What is this talking about? If you recall from our previous lesson where we learned how to calculate the mean of a set of data from a frequency table, we had something like this: S for the item, then F for the frequency, and Fx for the product of this item and the frequency, so that the mean from the frequency table then was given as summation Fs over summation F. But in this case, where we have group data, by the way, what is a group data? A group data is when you use an interval to represent a set of items within a given data. For example, this example is using a class interval of 10 to 19, 20 to 29, and so on and so forth. We have to calculate the mean of this set of data. In this case, there is no particular item that will fit into this X column here. So for us to get the X column, we will use the class mark of each of the interval. The class mark of each of the interval will fit into the S column. That is what this statement is saying, that in such a situation, the class mark or midpoint of the individual class interval is used for the S column. And recall that to get the class mark, we add the lower class limit to the upper class limit, then divide the result by 2. So for this first set of, for this first interval rather, the class mark there will be 10 plus 19 divided by 2. 10 plus 19 is 29. 29 divided by 2 is 14.5. While for the second interval, the class mark will be 20 plus 29, then divided by 2, which is 24.5. So all of this number, 14.5, 24.5, will fit in the S column. That is what this statement is saying, that in such a situation, the class mark or the midpoint of the individual class interval is used for the S column. So to solve this question, we are going to prepare a table that reflects what we are talking about. Let's get rid of this first. So have class interval, class mark, which will form the X now. So let me put in bracket S. And the frequency, which is F. And finally, F times S. The first interval is 10 to 19. The second is 20 to 29. The next will be 30 to 39. It's a difference of 10 in each of the interval. The next will be 40 to 49. What is the highest item here? I have up to 60, 64. Let's still continue. I have 50 to 59. 60 to 69. I think 64 is the highest item there, so I can stop here also. Let's check. Oh, we have up to 72, but we'll still continue. 70 to 79. Okay, now the next thing is to count, or is to calculate rather, the class mark for each of the class interval. So as I said earlier, the class mark is obtained by the summation of the lower class limit, the upper class limit, then divided by 2. 10 plus 19 divided by 2 is 14.5. 10 plus 19 is 29. 29 divided by 2 is 14.5. Then 20 plus 29, 49 divided by 2, 24.5. 39 plus 30 plus 39 is 69 divided by 2. That should be 34.5. When looking at this, you see that there's a pattern between the number. It's just a difference of 10. So my next interval should be, or my next class mark rather, should be 44.5. That is, I add 10. The next should be 54.5. The next should be 64.5. And the final one should be 74.5. What we are doing here is to add the lower limit to the upper limit and divide the result by 2 to give us the class mark, which we are using as our X item. Remember, X stands for the item in each of the intervals. So for the first interval, 10 to 19, how many items fall into that? 1, 2, 3, 4, 5, 6. There are 6 altogether. So the frequency there is 6. Then 20 to 29, how many fall in there? 20 to 29, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Have 10 there. Then 30 to 39, how many items fall in there? 30 to 39, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Have 13 items there. 40 to 49, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Have 10 there. Did I miss anyone? Okay, 11. Then 50 to 59. 1, 2, 3, 4, 5, and 6. Have 6 there. And 60 to 69. 1, 2, and 3. Finally, 70 to 79. Only 1. So fx will be 14.5 multiplied by 6, 24.5 multiplied by 10, 34.5 multiplied by 13, and so on and so forth. Let's get to calculator and do that. 14.5 times 6, 87. 87. It should be 245. I just move the decimal point by one position because this is 10 I'm multiplying by. Then 34.5 rather. 34.5 multiplied by 13, 448.5. 448.5. And the next one, 44.5 times 11 is 489.5. 54.5 times 6 is 327. And 64.5 times 3 is 193.5. 74.5 times 1 is still 74.5. Then we need to add up the summation fx. Summation fx is the addition of all these items in this column, which give us Let me write it down because that space is too small. 1865. When we add up all of this number, we have 1865. Then summation F, of course, you can even get that from the question because the question says the mass of 50 students. To confirm that, you can add up by yourself with your calculator. So the whole of this should be 50. So that the mean S bar, which is summation Fx over summation F from a table, is 1865 divided by 50. And 1865 divided by 50 is 37.3 kg. 37.3 is the mass, the mean mass of the student. So calculate the mean weight. So the mean weight is 37.5. Okay, another way we can get the arithmetic mean of a set of data is to make use of what we call the assumed mean. So when the data that is being considered consists of large items, a shortcut to get the mean is to make use of an arbitrary number from the list of items being considered. And that arbitrary number is what we call the assumed mean, AN. So the arbitrary number calculating the arithmetic mean is the assumed mean. To avoid ambiguity as to the value, the assumed mean should take a number very close to the middle score. The deviation, that is, the assumed mean subtracted from each of the items, which is denoted by D of each score, is found. The mean of all the deviation, called the mean deviation, is calculated. The actual arithmetic mean of the distribution is the addition of the assumed mean and the mean deviation, meaning actual arithmetic mean is assumed mean plus mean deviation, where A is assumed mean, D is deviation from the assumed mean, F is frequency, and X is arithmetic mean. Therefore, you can say that the arithmetic mean, when making use of assumed mean, is S bar equal to assumed mean plus the sum of the deviation from the assumed mean divided by the sum of the frequency. We have an example here. It says, using an assumed mean of 14 years, calculate the mean age of the following set of 9 members of the household. How can we do this? First of all, we need to arrange this data in a table, starting with the least one there. Let me call the first one X. Then the deviation from the mean, let me call it D, which is S minus assumed mean. The first one, the lowest here is 12, followed by 13, followed by 14, 16, 16, then 19, 22, 26, and 35 and 43. 35 and 43. This is a data arranged rather, according to their size. Now we're going to get the deviation from the assumed mean. We're going to get the deviation now, which is each of these items minus the assumed mean. We are making use of the assumed mean of 14. Here we have 12 minus 14, which is minus 2. 13 minus 14, which is minus 1. 14 minus 14, which is 0. 16 minus 14, which is 2. 19 minus 14, which is 5. 22 minus 14, which is 6. 26 minus 14, which is 12. 35 minus 14, which is 21. Then finally 43 minus 14, which is 29. The summation of all of these deviations is 74. That is when we add up all of this, the answer should be 74. And remember that our arithmetic mean, making use of assume mean, is assume mean from the assume mean plus summation FD over summation F. Summation F, we don't have the summation F in our table. So in this case, how many data do we have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have 9 there. With S bar, A plus summation FD over summation F will be, the assumed mean is 14. 14 plus 74 all over 74. How many did I count then? 1, 2, 3, 4, 5, 6, 7, 8, 9. All over 9. 74 divided by 9. 74 divide 9. 8.22. Our arithmetic mean will be 14 plus 8.22 is 22.22. And that is it for the first example. I'll have another example here. I say the table below shows the shoe size worn by some employees. Using an assumed mean of 72 millimeter, calculate the mean size of the distribution. With this table, this data is we'll have X, then we'll have frequency. We also need to have deviation from the, which is S minus the assumed mean. The first set of data that we have for 58, the frequency is 5. We have 61, the frequency is 7. We have 64, the frequency is 4. We have 72, the frequency is 3. We have 75, the frequency is 4. We have 78, the frequency is 6. Then lastly we have 82, the frequency is 1. And deviation from each of these, and we're making use of the assumed mean of 72. So I will have 58 minus 72, which gives me minus 14. And 61 minus 72 minus 11. 64 minus 72 is minus 8. Then 72 minus 72 is 0. 75 minus 72 is 3. 78 minus 72 is 6. And 82 minus 72 is 10. Then we need to have another column here again, which is FD. That is the frequency multiplied by the deviation from the mean. 5 times 14 and minus 14 rather is minus 70. 7 times minus 11 is minus 77. 4 times minus 8 is minus 32. Then 4 times times 0 is 0. 3, this goes here, this goes here, this goes here. This 3 times 0 is 0, rather. Then 4 times 3 is 12. 6 times 6 is 36. 1 times 10 is 10. And finally, we need to get summation FD. Summation FG. When we add up all of this number, we have 121. That is minus 121. Then summation F. How many students are we working with? We need to add all of this. We need to get summation F. Summation F, if we add all of this number, we have 30. 5 plus 7 is 12. 12 plus 4 is 16, plus 3, 19, plus 4, 23, plus 7, 30. So this is 30. Therefore, the arithmetic mean will be assumed mean, which is 72, according to the question. 72 plus negative 121 over 30, which will be 72 plus negative 121 divided by 30 is negative 4 point, negative 4.03. And we know that plus times minus is minus, so this will be 72 minus 4.03, which is 67.97 millimeter. So the mean, according to the question, the mean size of the distribution is 67.97 millimeter.